All right, good morning. Happy Monday. Hope you had a good weekend. Welcome back. So I'm just going to get you guys started on today's lesson. I'll try and keep this brief. So today's goals are to model cellular respiration, and this is the process that allows us to get energy from our food. So we're finally going to see how it is that you get that energy out of your food. Until today, we've just really talked about growth. So for our roadmap, we left off on Friday with some expressing ideas about how does Christian Bale get the energy he needs to dance. And we're going to go back up now to the top and we're going to do some modeling. And this time we're going to use those plastic molecular modeling kits, the ones with little blue and red, and white and black atoms and little macaroni noodles that hold them together. So in the big picture here about how animals use food, we're now in that bottom circle, the energy circle for cellular respiration. This is the process that we use, cellular respiration, to get energy from our food. And this is happening inside of the cells. There we go. So there's a lot of different movement going on here. So let's just take a moment here. So that dark blue one, that's oxygen going in. And you can see the pink one, that's glucose going in. And those two arrows are ending up in the leg cell of a cow. And then coming out is some water and some carbon dioxide. So lots of movement going all over the place here through different systems. And we're really going to be focusing on what's going on in that leg. So which ones, who are our key players here? These are the stars of our show today: water, carbon dioxide, oxygen, and glucose. And I know that glucose one is really ugly, but you are going to be building it today, and it's not so bad. It's not so scary. Okay, we'll walk you through it. So how do they move through the cow? So we're going to be zooming in eventually into that leg cell. But to get there, those molecules all have quite a ways to go. So I'm just going to pause here so you can watch. So watch perhaps the oxygen. You can see that oxygen's moving along and into the leg cell. You can see the glucose is moving along the pink arrow to go into the leg cell. And then coming out is water and carbon dioxide. So clearly something is happening inside that leg cell, this chemical change that's causing this to happen. So if we were going to zoom in on that leg cell, you can see glucose and oxygen are going in, and out come water and carbon dioxide. So something's got to be happening in there, that chemical change, where we're actually going to be extracting that chemical energy from our glucose. So we're going to be modeling that today to see what's really going on. How do we get energy out of these molecules in this process called cellular respiration? But to do that, I want to remind you of our rules about how atoms bond. So keep in mind, atoms and stable molecules always have a certain number of bonds to other atoms. So carbon likes to have 4, oxygen has 2, hydrogen has 1. The way I've been saying this is honk 1, 2, 3, 4, H1, O2, N3, and C4. But there's going to be no nitrogen today. Then keep in mind that oxygen atoms don't bond to other oxygen atoms if there's a carbon or hydrogen around instead. So you shouldn't be putting two oxygens together unless you absolutely have to. And chemical energy is stored in the bonds between those atoms. So the carbon-carbon and carbon-hydrogen bonds have high chemical energy, and you're going to need to use twist ties to indicate those. But the other ones, carbon-oxygen and oxygen-hydrogen, those are low chemical energy. It's not that they don't have any, it's just that it's low, but they're not going to get twist ties on them. All right, so that's the introduction to today's lesson. Mr. Shu has some directions for you to get all your stuff that you need. Please, at the end of the lesson, though, make sure you clean up so that the next class has all the supplies that they need as well. That would be great. That would be very helpful. Thanks so much, and good luck.